Hello, this is Mr. Stansbury. I'm going to take you through the notes on Vertex Form. At the end of this, you should be able to say, I can write a quadratic function in Vertex Form and graph the function. Okay, so first, from Algebra 1, and actually I think we talked about this earlier this year as well. If you've got a quadratic function, f of x equals ax squared plus bx plus c, we know that the axis of symmetry will be x equals negative b over 2a, right? With b being whatever's in front of the x, and then a being whatever's in front of the x squared, right? The coefficients. So, with that, this gives us the x-coordinate of the vertex. So the axis of symmetry, x equals blah, 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 that's actually also the x-coordinate of the vertex. Once we have the x-coordinate of the vertex, to get the y-coordinate, we simply plug in the x value back into the original equation, and that will tell us what the y-coordinate of the vertex is. So from this here, and using our axis of symmetry formula, we can actually come up with the vertex of this parabola here. Okay. Now also, once we have the vertex, we can actually rewrite the quadratic function that's in this form. We can write it into vertex form, which is what we've been looking at in the last couple of sections. Okay. So probably the easiest way to do that is to just take a look at some examples. So let's do that. Okay, so let's look at these examples here. Write each equation in vertex form. So that's the first thing we're going to do because they're going to ask us a bunch of things. To identify the vertex, the axis of symmetry, state which direction the graph opens. That's the fourth thing, and then graph. So they're actually asking us 5 things. We're going to do 5 different things on this, which sounds like a lot, but actually, once we actually find the vertex, pretty much the rest of this is going to fall into place. So, if you'll remember from our previous page here, to find the vertex, let's find the axis of symmetry, because the axis of symmetry, the x equals, is also the x-coordinate of the vertex. So let's do this. Vertex. Let's find what our x and our y is. So to find the x, we'll do x equals negative b, which is this 12 here, negative 12, all over 2 times a, which is this negative 2 here, right? So we've got x equals negative 12 over negative 4, which simply gives us that x is 3, right? So our vertex is 3. Now, super important to make sure that you keep really good track of all these signs here, because if you end up missing a sign here, you get that this is negative 3 instead of positive 3, it's going to throw off everything else in the rest of your equation. So you want to make sure that you're paying real close attention to detail here, okay? So we got negative over negative, just double checking it. Yep, x equals 3. Okay, so now that we know that x equals 3, we can actually plug this 3 back into this original equation here and figure out what the y is going to equal, right? So y is going to equal negative 2 times our x, which we now know is 3, squared, plus 12 times our 3, which is our x, minus 17. Okay, and let's see what that gives us. So remember, you got to do 3 squared first before you multiply by negative 2. That's a common mistake that I see a fair amount. So 3 squared is 9. 9 times negative 2 is negative 18. Right? And then 12 times 3 is positive 36. And then minus 17. So let's see. That is 18 and 17 together is 35. So really this ends up being negative 35 plus 36 gives us that y equals 1. Okay? So now that we have the vertex, which is actually this one right here, part 2, we actually also have the axis of symmetry, x equals 3. There's our axis of symmetry. So see, we've already done a couple of these. Now what we want to do is write this function in vertex form. So there's our vertex. So if you'll remember, vertex form is all that stuff that we've been dealing with in the last few sections here. So it's going to be y equals something squared. Remember, this over here is the vertical shift, right? This is x plus or minus something. This is our horizontal shift, right? And then the number that goes out here, this is our vertical stretch or shrink. Stretch, shrink. I know you can't read that. I can't read that, so I'm just going to get rid of that. So let's leave it as vertical stretch for now. You get the idea. Okay, so we know that so the vertex, if we're going to graph this thing, we know is at 3, 1. It's supposed to start here at 0, 0, right? But now we know it's actually over at, let's see, it's to the right 3 and up 1. Here's our actual vertex. So that means this vertex shifted up 1. So there's our vertical shift, plus 1. It also went to the right 3. So what this means is that this is 3. And then 3 plus what gives us 0. And that's going to be negative 3. So there's our horizontal shift. Okay, so we've got those two pieces in place. And then our vertical stretch, this here is simply going to be whatever this number is. It's going to be whatever the A is. That's always going to be this vertical stretch right here. So that's going to be negative 2. So there is the equation in vertex form. So we've now done this part here as well. So it says state which direction the graph opens. Since it's negative, that means this thing's going to open down. So opens down. Right? So we've done 4, and then our last step is to graph, which we've already started. Okay? So remember that point there is not actually part of the graph. That is where the original vertex was supposed to be until we shifted it. Okay? Now, if you remember to find the next point, we do negative 2 over 1. So we go down 2 to the right 1, and we also mirror image that along this axis of symmetry, right? Which is this little thing. You do not have to draw the axis. Didn't ask us to draw the axis of symmetry, but just so you kind of understand it, that's the line x equals 3, right? So we know we can reflect that over this axis of symmetry as well. So we go down to the left 1. And there's 3 of our points. We always want to have 5 points. So I'm just going to do an x and a y. And I want to do, let's see, I want to do the next one to the left over here. So I'm going to plug in 1 here. And I also know that I'm going to want to plug in 5. But since this is a parabola, I know that whatever I get for my answer for 1 is going to be the same answer for 5. So now I just want to plug 1 into our original equation and see what we get. So we go negative 2 times 1 squared plus 12 times 1 minus 17 is what our y value is going to equal. 1 squared is 1 times negative 2 is negative 2. 12 times 1 is 12. Negative 2 and negative 17 is negative 19 plus 12 gives us what? 6. Right? So we get y equals negative 7. So we go 1 and negative 7. We also go 5 and negative 7. You can always double check to make sure that it works with that, but it should always be the same. And so then now we're able to, oops, missed that one. Let's try that again, see if I can get it closer. That's a little better. And then we sketch our graph. Okay, so now we've done all 5 things that they asked us for. Okay, let's do one more here, but before we do that, let's take a quick little comedy break.
We thought he was sleeping, and all of a sudden I heard through the monitor, "Daddy, I have a joke for your career." I got like goosebumps, man. I'm like, wow. So I got to go up there, man. I ran upstairs. This is true. And I sit on the bed. I'm like, man, wow, you got a joke for my act, buddy? And he goes, yeah, I just thought of it. I was like, whoa. I wanted to cry. I was like so touched, you know. I was like, really? Wow. What's the joke, buddy? And he goes, how come dinosaurs don't talk? I don't know. How come dinosaurs don't talk? Because they're all dead.
All right. Let's take a look at B here. Let's do this in a different color just so it doesn't get confused with this other stuff over here. So we'll do this one in pink. All right. We are going to plug this into the x equals negative b over 2a, our axis of symmetry formula, right? So let's do this. X equals negative, b is 6, all over 2 times a, which is 3. All right, so we get x equals negative 6 over positive 6, so our x is going to simply be negative 1. So our vertex for this thing is going to be negative 1. And again, just double check to make sure we've got it. Negative b, negative 6 over 2 times a, 2 times 3. So that's negative 6 over 6. Yep, because we don't want to mess that up. That'll mess the rest of the problem up. So our vertex at negative 1 to find, well, the x value is negative 1. And it's also our axis of symmetry. This is our axis of symmetry, right? Which is also, I just refer to it as the AOS, axis of symmetry, x equals 1, negative 1. So to find the y value, we plug our negative 1 in for all of our x's, right? 3 times negative 1 squared plus 6 times negative 1 plus 1. Negative 1 squared is 1 times 3 is 3. 6 times negative 1 is negative 6 plus 1. Negative 6 plus 1 plus 3 gives us negative 2. So we get negative 1, negative 2. Okay, so there's our vertex. So again, we've already done the vertex. We've done our axis of symmetry. Might circle all these just so we can find them later on. Okay, and then let's see. So now let's use that to now rewrite it into our vertex form, right? So vertex form is going to be y equals something in front of there with an x plus or minus something out there, right? This negative 2, the y value is always our vertical shift, right? So that's just going to go straight down there to negative 2. This x here is negative 1, so I think negative 1 and what gives us 0? Negative 1 and positive 1. Or again, a lot of people just say, oh, I'm going to take the opposite of this negative 1 and put positive 1 in there. That works just fine too. Okay. And then the number out front here is going to be the same as our a value. So this 3 is going to go in right here. So there is our function in vertex form. Okay, so we've done that as well. State which direction the graph opens. Since it's positive, the graph opens up. Right, so we did that. And then our last thing is just to graph this. So our vertex is at negative 1, negative 2. Our next point is going to be whatever's in front here, 3 over 1. So we're going to go up 1, 2, 3 over 1. Up 1, 2, 3 over 1 that way as well. And then we want to get 2 more points. So we'll do x and y. And again, remember we only have to calculate it once. So let's see. I would rather put in 1 than negative 3. So we want to do 1 and negative 3, 1 on each side, make our life easy. So I'm going to plug in 1 here to our formula. Y equals 3 times 1 squared plus 6 times 1 plus 1. So 1 squared is 1 times 3 is 3. 6 times 1 is 6 plus 1. So we get y equals 3 plus 6 plus 1 gives us 10. So that's going to be 10, and negative 3 is also going to be at 10. So 1's at 10, negative 3 is also at 10, and now we can sketch our graph. Okay? Okay. That's all we have for vertex form. If you have any further questions, please feel free to ask in class. Thanks.